Hi, Sam. Can you hear me? Hello. Hello, Sam. Can you hear me? This is Stacy. Sam, can you hear me?
Good afternoon.
Good afternoon. How are you?
I'm okay. Are you able to hear me? I mean, I don't know whether I can. Is my video on? I don't know.
No, your video is not on, but I can hear you. I was trying to hear Sam, but I cannot hear him. Oh, there
Okay,
you
so
are.
I just turned my video on.
Okay.
Are you able to see me?
I see you.
Okay, thanks.
How are you?
I'm okay. How are you, Stacy?
I'm
So,
well. Thank you. Thank you for joining us.
Sure.
I
Is
see it.
Sam on?
He's on, but I cannot get him to, hold on. I can't
Hey,
hear
Linda.
him. Hi, Lyndon. Okay, Sam, I'm going to make him another panelist again. Let's see if he can. Hi, Sam.
Hi.
Hey,
Can you hear me?
Sam. Yes.
Okay, I hear you now.
Cool.
Okay, great. So we're going to troubleshoot for the moment. If you can, are you able to share your screen? Is it
Yeah,
great?
let me try doing that. Where?
On the right-hand side, it should say, well, wait a minute. I think I have to make you, I'm going to change the presenter over to you
Okay.
and see if you can share your screen and advance your
Okay.
slide.
I have to open system preferences. It might make me quit and rejoin.
Okay.
I've never used GoToMeeting before. Yeah, I'll have to quit and reopen. So I'll
Okay.
do that, I guess.
Yeah, that's good. And Lyndon, do you have a copy of the questions sheet? I think you're on mute.
Yeah, I was on mute. Okay, I put it in the chat. Do I have the right one?
Yes, that is the right one. And then what you just have to do is just continue to when it starts about every 10 minutes or so, it'll flash and it'll get the audience attention for them to put their questions in the chat box. And who else? Okay, Sam is back. Let me take him. Yeah.
Hi again. Can you hear me still?
I can hear you but can't see you.
Okay. Oh, I have to share my webcam.
Mhm.
Okay. You can see me now?
See you and hear you. And so let's see if you can show your screen to show your
Okay.
slides.
So wait, where do I do that?
On the right, it should say webcam. On the right-hand side, it should say, let's see.
Because in like under the webcam heading of the strip with all the settings,
Mhm.
I only have the option stop sharing my webcam or hide my webcam.
All right, let me see. Because right now you are a presenter. I see you in here twice though. I don't know what that is all about. Let me make
Probably
you.
for quitting and joining.
Okay,
Well, there are
see.
5 attendees, so that's what. Is that what it is? 5? We are only
It's
4.
4 of us, but I see your
I
name
see.
in here
Yeah.
twice. But I'm gonna make you
Yeah,
see.
I think.
Yeah, see if you can share your webcam now.
Okay. You guys froze on me though. Okay. I guess you could see everything now, but I can
Okay.
share just Chrome. Okay.
Your presentation.
Okay.
And see if you can advance. Okay, good.
Cool.
Great. So we sometimes have issues with that. Once we start the broadcast, and for some reason, people can't advance their slides or some type of trouble. So that's why we're here. So for right now, I am going, in the beginning, I'm going to do the introduction, and I will stop sharing my screen. I'm going to share my screen. So you're going to give me back
Okay.
permission to your screen. So, okay. So once I finish the introduction, then I will give you back the permission to share your screen, and Krishna can introduce you.
Okay. Cool.
Okay. So we have like a few minutes left. I'm going to turn my camera off and do a little bit of troubleshooting real quick.
Cool.
Stacy, I have a
Yeah.
question. Lyndon, are you going to take care of the questions?
I'm going to make sure that the document for questions is shared regularly. And I'm going to be letting people in.
Yeah.
Stacy
Okay.
can focus on.
Well, we're all in now. We're all in. So Sam, after you finish your presentation, you can click questions document, and you read your questions and answer them accordingly.
Okay. And are you able to, by chance, make make Mao Yi and Leah panelists too? Because it's possible I'll have to redirect some questions to the Epic team, since I've not really been involved with that for the past 10
Leah
months.
and Maui?
Yeah.
Yeah.
Sure. Do they
Maybe
know?
Epic related programmatic aspects of it, like, like a release and all those things.
So once you want to reference them, if Lyndon, if you can go in and make them panelists, you click on the attendees and then look for their name and just make them panelists, and then that way that they should be able to get in. Okay.
Cool.
And I'll start the broadcast once 3 o'clock hits. All right, let me go off. And then Lyndon, once we do start, you can turn your camera off once we do start. And Sam, you keep yours on. Krishna, you can keep yours on for your introduction.
Okay, we'll do that. Sam, would you mind sending me your copy of the final presentation to me? Just through email. Yeah.
You're on mute.
You're on mute.
Yeah, I could send you the link. It might actually already be shared with you, but I'll send it again because
Okay.
it's just the same doc as previous.
Okay.
Okay, we have a couple more minutes. Can you see my screen?
Yes.
Okay.
1 second. We
The
have 3
webinar
minutes, right?
shortly. Please remain on the line.
Sam, could you send me one more time your bio? I have it. I mean, I
The
am not
webinar
able
will
to.
begin shortly. Please
Yeah.
remain on the
Yes.
line.
The short bio that you sent. Yeah.
Yeah.
And 2 more minutes. I will start. Well, yeah, 2 more minutes. I'll start.
Did you send it to me?
No, how did I share it with you originally?
I think you send it through the dry run, and that's what I think from there. I'm just trying to get it. I had it somehow, it just disappeared. Oh, okay, let me see.
Okay, I'm about to start. Few seconds.
Stacy, do you have Sam's intro?
Let me see. Uh-oh.
I had it somehow, it just disappeared somewhere.
Let me, Sam. Let me see. Oh yeah, I'm gonna send it to you now.
Okay.
I can't talk. I'll call you right back. I'm gonna go back up there. I can't talk at all. I've just sent it to you. I'm sorry. Wait a minute. It's going to Krishna. Okay, so I'm about to start now.
Okay.
Hello and welcome to the UFS webinar. This webinar is hosted by the National Weather Service, Office of Science and Technology Integration. The goal of this webinar series is to enhance communication and share advancements in all aspects of the UFS in both research and operational settings. I am Stacy McKell, and I'm here to help to coordinate and deliver the webinar. Feel free to contact us at OSTI if you have any comments or suggestions. Also, if you have any recommendations for speakers that you would like to present at this webinar, you can email your recommendations to ufs.modeling@noaa.gov, and we'll take your suggestions into consideration. Due to the high number of attendees, you'll be in listen-only mode during the event. You will not be able to unmute. If you have any questions now or during the event, please submit them on the Google document that will be provided in the chat box. Presentations last about 45 minutes, followed by questions and answers for 15 minutes. Type your questions in the Google document during the presentation. Okay. And today's speaker, sorry. Today's presentation will be migrating the UFS graduate student test to the cloud. Before we begin the presentation, I'd like to show you how to get our presentations. You go to the United Forecast Systems webpage and go to the portal. Scroll down to the events section and you'll see the webinars listed at the bottom of the page. Okay, and today's speaker will be introduced by Krishna Kumar. Krishna, I will turn it over to you.
Good afternoon, everyone. I would like to welcome Sam Ephraim. He's from the Chicago area, and he has recently graduated from the University of Michigan, earning a BSc in climate and meteorology, concentrating in meteorology, and also a BSc in computer science. This coming year, he will be a professional master's student at the University of Miami, concentrating in weather forecasting. He was, in 2021, he was a William LePenta intern representing the EPIC program, where he worked in NOAA WPO EPIC to create documentation to run the UFS graduate student test in the cloud. And outside of his studies, he loves to sail, and he was on the University of Michigan sailing team as an undergrad, and he continues to sail locally. So welcome, Sam. So take it away.
Thank you so much for the introduction. So today I'll be talking about my project as a LaPenta intern, which was migrating the UFS graduate student test to the cloud. Let me just fix this window. Okay, well, that's fine. All right, so as Krishna mentioned, I recently graduated for the University of Michigan with degrees in meteorology and in computer science. Next year, I'll be pursuing a professional master's at the University of Miami, concentrating in weather forecasting. And then my favorite hobby is sailing. As Krishna mentioned, I was on the sailing team for my whole time at Michigan. And here's two pictures of me sailing when I was on the team. So first I'll talk about the LaPenta internship experience as a whole. So the LaPenta internship is a 10-week internship named in memory of Bill LaPenta that has around 50 students dispersed across various NOAA offices. Those happen to be across 3 line offices: the National Weather Service, NESDIS, and OAR. And we also got to visit many different labs and office centers virtually throughout NOAA, and we got to learn about their operations and get virtual tours. My project was in the weather program office in the EPIC team, and I worked on the UFS graduate student test, which I'll explain in a bit. So first I'll talk some about the UFS and EPIC. So currently the operational forecast systems of the National Weather Service are 21 independent standalone systems. The most commonly known are the GFS, the NAM, the HER, but there's many more. And the goal of the UFS is that these will be unified into a single development environment with various applications for different use cases. For my project, I worked a lot on the medium range and the short range weather models, but there's also many more, ranging from hurricane apps to lakes to air quality, etc. So EPIC was created after a congressional act in 2018 to help the US create the most reliable and accurate numerical weather model in the world. And the goal of EPIC is to help the community get involved in creating the UFS. Currently, when this act was made, the Euro, the ECMWF, had a lot more research, had much more research than the GFS and the other American models did. So to increase the breadth of the amount of research and innovation going into the models, it's important that the general community can get involved as opposed to just employees at NOAA. And so EPIC is designed to be the catalyst behind this community research and modeling system advances to help the US have the best model in the world. And the goal is that EPIC will focus on the UFS, and that it's important for that the cloud is able to be used, because that'll help make it much more accessible to run the UFS. So here's the workflow of how the community modeling works. So there's all the UFS code is in a repository, and there's extensive documentation on EPIC's website. And from there, the community is able to upload or is able to download that code to their own computer or to the cloud or wherever they want to work, and create innovations and development. And then after the community does that development, they're able to actually bring that back into the UFS code repository, and eventually through a vetting process of testing and validation by the research community, the goal is that it'll end up in the operational model at NOAA. So for my project, I worked a lot on the operations to research in getting the community the access to the code and being able to run the code through using cloud resources. And one of the main ways that EPIC gets new people involved in the UFS is through the UFS graduate student tests. What the UFS graduate student test is a usability test that tests how easy it is to run the UFS short range weather application or the UFS medium range weather applications. And the goal is that it's easy enough that a student should be able to complete it in less than 8 hours. And it helps engage young scientists that will hopefully contribute to the UFS in the future. And it also helps the developers get feedback on the ease of use of the UFS code. So the process of completing a graduate student test is first downloading the code from GitHub, and then running the control case on their local computer. And then there's an experiment case where the user modifies and reruns the code, and then they get to plot and compare results of the experiment and control runs. So the objectives of my project were to create documentation to run containerized versions of the graduate student tests in the cloud, and that they'd be able to be completed in the less than 8 hour benchmark. And I also coded plotting scripts in Python to help display model output for the medium range weather application. And the benefits of this work are increased accessibility for running the UFS GSTs, and that there'll be improved visualization of the medium range weather application results, which will make it easy to run and visually appealing. And hopefully all this sparks interest in young meteorologists that will hopefully contribute to the UFS in the future. So first, I want to introduce the team that worked with me last summer. So my mentors were Krishna Kumar and Henrique Alves. And then I also had a technical support team that helped me out with a lot of the technical questions I had throughout the project. And they also provided resources for me to complete my project. So that's Min Suk Ji, Dom Heinzeiler, and Ligia Bernadette. So first, I'll go through a brief overview of cloud computing. So cloud computing is the on-demand availability of computing resources that's not actively maintained by the user. So the user does not need to have servers and server racks or access to HPCs to be able to use compute resources needed to run the UFS. And it's also a pay-as-you-go model, so you only have to pay for the amount of time you're using the resources, and it's relatively cheap. For this project, there are many cloud service providers, but I used Amazon Web Services, AWS. And some of the advantages of being able to run the GSTs in the cloud are that it makes it much more accessible. All that's needed to run the GST is an internet connection. Previously, you would have needed access to a HPC or a personal computer that met all the specs needed to run the UFS, MRW, or SRW apps. Also, it's faster than if you were able to use your personal computer, because you're able to use better resources than you would have on your local machine. And it's also relatively cheap because it's pay-as-you-go pricing, and it's about less than $1 an hour. And I'll go into a cost breakdown of what it approximately takes to run the GST later in the presentation. So there are many ways to run code in the cloud, but one way of running code is inside of containers, which is a unit of software that includes all the libraries and code needed to run the app. And so that saves a lot of work, setup work for the user, since they don't have to build all these libraries, such as nsep_libs and nsep_libs external. So an application such as the SRW or MRW apps can be run inside of a container, and there are many different container softwares, but for this project, I use Docker. So first, I'll go through some of the completed work throughout the internship, which is on the medium range weather graduate student test and the UFS weather model regression test. So the medium range weather app graduate student tests, the goal is to compare cloud cover forecasts during Hurricane Dorian using different cloud condensation nuclei constants. So I was able to create documentation for running a containerized version of the MRW GST in AWS. I wrote an FAQ section to help new users resolve issues and coded new plotting scripts for users to visualize experiment results. So next I'll go through, I'll skim through the documentation just to show you what it looks like. So first, I have the description of the test, and that we're going to be testing changing the cloud condensation nuclei constants. And then I go into detailed instructions of how to configure cloud resources. So there are two different options I made documentation for. One is using AWS Parallel Cluster, which anybody can use and make an account. You would have to pay, but it's relatively cheap, as I'll show in a few slides. And then I go through how to set up a cluster with instances that are powerful enough to run the MRW. And then I also go into how to set up your compute resources on ParallelWorks, which is a NOAA front end for using AWS. Next, I go through instructions on how to install Docker. I used a container, or I installed Docker here, and then next, downloading and running the container. So for my project, I used a container that Minsuk built, and this saves a lot of time building libraries, as mentioned previously. So next, it goes through how to run the control case, which uses a 100-kilometer grid size, higher, which is what the GST calls for. And then it goes through how to run the experiment. So this shows how to modify the cloud condensation nuclei constants in the model, and then also rerunning the code. And then it goes through how to compare outputs and creating plots. And then finally transferring those plots and GIFs back to your local computer so you can see the results. So first I'll talk about the plotting routine. So previously there was the output of the MRW was plotted using NCL, which stands for NCAR command language, which is an outdated library that I had difficulty downloading, and it does have a reputation for also being difficult. And what it did was it plotted cloud fraction for the control and experiment runs, as you can see on the left-hand side of the screen. And then on the right-hand side of the screen is a plot of the difference between the control and experiment runs. I created a new plotting routine based off of scripts that were written for the short range weather application. And it uses Python. And in addition to just plotting the cloud fraction for the control and experiment runs, I also added functionality to plot 2-meter temperature, 10-meter wind, cloud fraction, and quantitative precipitation forecast, along with functionality to create a forecast loop GIF, which is something that the SRW plots did not have either. So here's an example of the plots. So this is for the GST. So this is Hurricane Dorian. You could see in the left-hand panel the wind, and you could see right now Hurricane Dorian moving towards the Bahamas and the east coast of the US and strengthening, and then it'll move up the coast. And having a visualization like this, like as someone new to running the UFS on your own computer, seeing a visualization will help people get more excited about what they just did, since they can see that they just made this forecast themselves. So overall, the time breakdown for running the MRW GST does meet the less than 8-hour benchmark, and the majority of that time is just having the model run. So having the control case and experiment case run. Only about 2 hours of time is actively needed to run the model. And then the cost breakdown. So for the MRW, I used a C5N 2x large instance, and it costs less than 50 cents an hour. And then for an EC2 NAT gateway was about 5 cents an hour. But overall, the cost over the 8-hour period of running the MRW is less than $4, which is really affordable and opens up access to running the MRW to a large breadth of people. So I briefly mentioned NOAA Parallel Works. I use NOAA Parallel Works mostly during my internship because I had access to NOAA resources, and so this is how people at NOAA can access AWS. Now, also, in addition to just using it, I was able to help resolve some bugs with the cost dashboard. The cost dashboard showed very delayed and in error stats for how much resources I cost. And I was able to get that feedback back to the developers, and they were able to fix a lot of things up. So I also was able to create documentation for the UFS weather model regression tests. And this runs the full test suite for the UFS weather model. And this is important because as new developers make changes to the model code, they need to be able to test their changes with the regression tests to make sure they pass all these tests. So having documentation to run this on the cloud opens up opportunity for a lot more researchers to be able to modify and test their new code. So some in-progress work that I wasn't able to fully complete during my internship, it revolves around the short-range weather graduate student tests. So this graduate student test compares model runs of the UFS using different grid resolutions and different physics schemes. So I was able to create a Docker container from scratch for the SRW GST that works for the 25-kilometer resolution control case. But I ran into some issues after that I'll talk about. And so I created documentation for running the control case in AWS. And again, wrote an FAQ section to help new users resolve issues. However, I hit a roadblock when I tried to run the experiment cases that used 3-kilometer resolution. I had a seg fault due to too little computational power of a single node, and I was able to create extensive documentation of this problem through emailing experts in the UFS and through forum posts, etc. And hopefully that helped solve this problem, which I'll get into a little later. So the suspected problem is that since using Docker, a Docker container constrained the model to only run on a single node, so the hypothesized solution at the time was to use a container service such as Docker Swarm that can run on multiple nodes and give us the computational power needed to run the high-res case. So overall, some of my accomplishments during the internship were that I was the first person to complete the MRW GST in the cloud. I was able to create documentation to run the MRW GST in the cloud. And in addition to the UFS weather model regression tests. I also was able to complete documentation to run the SRW GST control case in the cloud. And even though I wasn't able to do the high-res run, I was able to document my challenges and potential solutions that could help people in the future run the high-res SRW GST in the cloud. So some work, loose ends that I wasn't able to finish up were finishing the high-res case of the SRW, in addition to testing the graduate student tests on various cloud service providers, such as Azure and Google. So now if we fast forward 1 year, this past winter, I presented my work, an abbreviated version of this presentation, to the first symposium on Earth prediction innovation and community modeling. And I was able to share a lot of my work to a lot of people involved in EPIC. And since I left this project, an AWS Short Course has been created for running the short range weather app on the cloud, which ties up the loose end that I wasn't able to finish. And that was created and run by Jean-Miguel Farhat from NOAA, Dr. Mark Potts from NOAA, Dr. Jeff Beck from CIRA at NOAA GSL, Dr. Neil Jacobs, the Chief Science Advisor for the UFS, and Dr. Gerard Katafian from Ezra. And also a special shout out to DTC for helping make the course. So this course went through pretty much a lot of background about EPIC and the UFS, but the meat of the course was about how to run the graduate student test for the short range weather application, And it goes in depth through step-by-step how to set up cloud resources, how to build how to run the control case, how to run the experiment case, etc. And so that accomplishes the goal now of being able to run both the MRW and the SRW GSTs in the cloud. In addition, since last summer, there has been a new release of the UFS short range weather application, which is version 2.0. And some new capabilities are a new verification package, MAT+, for deterministic and ensemble simulations, and support for the 4 stochastically perturbed perturbation schemes. And future releases, some goals are to improve data assimilation and forecast restart and cycling. So now the loose end of finishing the high-res case of the SRW has been finished. And so in the future, though, testing the GST on different cloud service providers, such as Azure and Google, is still needed. So my future, I learned so much during this internship in within Epic, in working before this project. I did not do much terminal work besides just coding in my terminal based off a list of instructions. And I learned so much and feel so much more confident in that. And my favorite part within the project was creating the plotting scripts for the MRW. I love creating plots and analyzing data, and that fit in really well with what I like doing. And also, as I mentioned, we've visited a lot of other offices during the internship. And I also really liked the presentation by the NSSL, which talked about the development of a new tornado warning metric, which I found really interesting. And so in the future, I don't know exactly where I'll end up for my career, but this internship and working with Epic definitely will help me make my career decision after I'm done at grad school at the University of Miami. So here's some links to the MRW. There's documentation, which it goes to the Epic site, and this goes through the GitHub, the wiki, the user guide, which the user guide goes through detailed instructions through the workflow and how to set up and run the code on your own, regardless of whether on what platform you use it on. So it could be your local Mac or PC, an HPC. I don't think there's stuff here for configuring cloud resources yet, but if you go back to this link here, oops. If you go to the link that I went to earlier here, which is available, it's shared to anybody who has the link in NOAA, but I'll have an email at the end of the presentation that you could ask for that documentation to be sent for you, which shows how to run it in the cloud. And then there's also the graduate student test page, which has the graduate student tests, the instructions for running it not in the cloud. There's also the links for the SRW. So again, there's documentation here that goes through similar things as the MRW with the wiki, repository, and users guide. Again, similar detailed documentation. And then there's a link here I put for the workshop that was run by these people here in the past. And there'll actually be a new workshop at fall in AGU in this fall. So, and that includes the GST walkthrough as the main exercise for learning how to run in the cloud. So I know it's a little short, but I have a lot of time for questions. So I'll look through and see if I have any.
Thank you, Sam. So yes, you do have some questions. So if you can pull up the questions document in the chat, if you can get to it, you'll be able to see your questions.
Okay. Having a little trouble finding.
Okay, no problem. Let me. So do you see in the chat box, you see like a question box coming up and it's flashing on the right panel?
I do not.
Okay, let me send it to you 1 second.
Okay.
Did you get it?
Did you email it to me?
Yeah.
Okay. Let me. Okay. So yeah, I know I'm sharing my screen, but it doesn't help to. Will help. So yeah, okay. So the links, did I follow? Did the slides at the end answer that question? I don't know who asked that. Or were there other links that you wanted to see? Yeah, I could put up the last slide, and I think it'll be sent. The slide deck, I'm pretty sure, will be sent out to everyone too. So yeah, this is the email of the Epic team that you can send if you want to get the medium range weather GST documentation, since that's only link sharing is only allowed to people in NOAA. The other stuff, you should just be able to click the links directly. And then, yep, no problem. So I guess the reason that we ended up choosing to do the cluster was because originally I started only working on this project in NOAA Parallelworks, and NOAA Parallelworks is like set up to be used as like creating a cluster. So that was the easiest way to transition from running it in Parallelworks to running it just through the AWS command line interface or AWS browser, was to do something similar to what I've already done. But I think we did consider using it, but I don't remember that much. Let me know if I answered that or if you have more questions. But it actually leads well into the third question. So we did consider not using a container at all. Basically a container just, it makes it easier to skip steps for building the library, the unsep libs and unsep libs external libraries. So it lets you skip those steps, which can be kind of a hassle. And I think, though, after I had the issue with the SRW, I don't fully remember, but that's the reason though why we used parallel cluster, and the reason why we used a container, just ease of use. And then did I consider using the NOAA data app sets? I do not know. Does someone from the Epic team want to chime in with the fourth question?
So I know that you asked her to put Maui as a panelist, and she is. So if she wanted to unmute, she can.
Sam, this is Krishna. I think, NOAA has this NOAA Big Data project, and they have collaboration with all the cloud service providers, providing all the necessary data of various needs. And Epic team basically is providing a lot of regression test inputs, input data and other things precisely for that, purpose, like so that public can really use data from the cloud and use some of these publicly available, public release versions without worrying too much about, data. So that's the plan. Yes.
Cool. Oh yeah, and I see here, you could add your email address down here, and the documentation can get emailed to you.
I'll make sure you get a list of the email addresses, the folks that are entering their email address down there.
Thank you.
Mhm. Yeah, nice work. Thank you. This is very interesting. Anybody else have any questions? Feel free to type them in. I know it may take some time to type, but please do. A few more minutes.
Stacy, I think Mo is trying to chime in. Could you unmute her?
Maui should be able to unmute. 1 second. Maui, you are self-muted. You can unmute yourself if you can. I'm trying to. Okay, Maui,
Yeah, I
see.
would like to mention about the data bucket. BDP has been renamed to NOAA Open Data Program. So that's what I think, Mo is trying to remind. So yeah, we just want to mention that.
Go ahead,
BDP is now called NOAA Open Data Program.
Maui. Maui here is now unmuted, so she can. Maui, you can chime in.
You cannot hear me, right? Can you?
Yes, we
We
can hear
can.
you.
Yeah, now we can.
Oh, okay. Yeah, I was just trying to remind everybody, even though the data for the GST is not released, but coming with a short range weather application release, recently released on June 23rd, we released the data bucket through the NOAA Open Data Program already, and you can see that link on the question Q&A document.
Thank you, Maui. So it looks like we don't have any more questions. And Sam, again, thanks very much. Thank you, Krishna. It was a very interesting presentation, and all of the questions will be available for you to just to keep. And also the slides, and I know people were interested in the slides, they will be posted on the UFS modeling website along with the presentation, recording of the presentation. All presentations are recorded and placed on the website, so they will have access to that. Okay. And again, thank you very much. This was great work. Okay.
Thank you so much for having me. And thank you
Absolutely.
everyone for coming.
And I just want to remind everybody again, if you have any recommendations for anyone to present at one of these webinars, please feel free to email us at the OSTI ufs.modeling@noaa.gov. Okay, thanks everyone, and see you next month.
Thank you, Sam. Great presentation.
Yes.